All right, take two. This is our chapter one test review for trigonometry. All right, so these first five, it looks like, are your special right triangles. And we had two types of special right triangles. The first one was a 45, 45, 90 triangle, and we called it that just because the measures of each angle were 45, 45, and 90. All right, so now, one thing to keep in mind about this one is that since we have two congruent angles, we have two congruent sides, all right? So I'm going to go ahead and call these sides x, right? Now, we said to figure out, to go from the leg of the triangle to the hypotenuse, all you had to do was multiply by the square root of 2, all right? So this hypotenuse is x times the square root of 2, all right? So if x is 7, the leg would be 7, both legs would be 7, and the hypotenuse would be 7 times the square root of 2. If we wanted to go backwards, if I gave you the hypotenuse and you wanted to find the leg, just divide by the square root of 2. All right, and then sometimes we have to rationalize that. We'll cross that bridge when we get there. All right, so now the next one is a 30, 60, 90 triangle. All right, so this one has three different angle measures. So that means that the side lengths are going to be different. All three side lengths are going to be different here. So the smallest angle is always across from the smallest side. All right, so these two are going to match up. Smallest side across from the smallest angle. Now, I'm going to call the smallest side just x. To go from the smallest side to the hypotenuse, all we had to do was multiply by a normal 2. Right? So this is just 2x. To go from the smallest side to kind of the medium side, or if you want to think about that as the longer leg, you would multiply whatever that short side is by the square root of 3. Right? So multiply by the square root of 3. Right? Say you want to go backwards. If you want to go backwards, always divide. Anytime you go to the smaller one, you're going to divide. And again, sometimes, since we're dividing by a radical, sometimes we do have to rationalize these. All right, so let's just take a look at this first one here. So on number one, you got a 45, 45, 90. If you wanted to fill in the other angles, you can. So this is an isosceles triangle. So that bottom leg is going to be 7. Now the hypotenuse is just 7 times the square root of 2. All right, and that one's done. That's all we had to do. All right, now this next one, they give us a 30-degree angle. I can fill in that 60 down here. So we have a 30, 60, 90 triangle. But notice we don't have the short side. The short side is across from that 30-degree angle. So we kind of have to work backwards. So we need to take the 21 and we're going to divide it by the square root of 3. All right, so that shorter leg there is 21 divided by the square root of 3. And as we said before, we do need to rationalize this. So whenever you rationalize the denominator, all right, it's not complicated. All you have to do is look at what that denominator is and multiply both the top and the bottom of that fraction by that denominator. So we're going to have 21 square root of 3 over square root of 3 times the square root of 3 is the square root of 9, which is a regular 3. All right, but we're not done yet, because we can simplify this further. Right? Any fraction, you can always reduce it, or you should always reduce a fraction if you can. So 21 thirds is 7, so this turns into 7 times the square root of 3. That is the shortest leg here. All right, now to go from a short leg to the hypotenuse, double it. All right, so we're going to have 2 times 7 square root of 3, which gives us 14 square root of 3. That is our long side here. I'm sorry, that is our hypotenuse. All right. Now on the next one here, no angles. We don't know what the angles are, so we can't do we cannot put a 30, 60, 90 in there. You can't put a 45, 45, right? We don't know what that angle is. So let's just throw a letter in there. Let's go ahead and just call that x. All right. Think Pythagorean theorem here. A squared plus b squared equals c squared. I know we're going to have x squared plus 16 squared equals 18 squared. 18 is your hypotenuse. All right, the hypotenuse always has to be on its own side of kind of this Pythagorean theorem problem that we have here. All right, so what I'm going to do is I'm going to do 18 squared, right, and that's going to give me 324. Now, I got to get rid of that 16 squared, so I'm going to subtract it. So I'm going to say 18 squared minus 16 squared. All right, and that gives me 68. So we know x squared here equals 68. All right, we just got to think, how do you kill a square? Well, you square root both sides. All right, so we know x equals the square root of 68. All right. Now, just like with any radical, just like any fraction, you simplify a fraction, you should always try to simplify radicals. So what I'm going to do is I'm going to divide 68 by some perfect squares that I know. All right, so like 4. 4 is a perfect square. So this turns into the square root of 4 times the square root of 17. Right. Now the square root of 17, that's nothing. All right, but the square root of 4 turns into a normal 2. So your final answer here is 2 times the square root of 17. And that one's done. First 3 knocked out. All right, we're going to speed this up a little bit. So this one, 45, 45, 90, divide by the square root of 2. So this leg down here is 8 over the square root of 2, but we need to rationalize that. All right, when we do rationalize that, that turns into 4 square root of 2. All right, so 45, 45, 90, that means this leg right here, kind of the vertical one, that's also 4 square root of 2. So now let's just highlight this whole triangle here, this blue one. Now, that is across. So to go from the short side to the hypotenuse, just double it. So this hypotenuse here is 8 square root of 2. All right. And then the bottom part is going to be 8. No, it's not. The bottom part is going to be 4 square root of 2 times the square root of 3, which turns into 4 times the square root of 6. All right. Now on number 5. 30, 60, 90 triangle, they give us the hypotenuse. All right, so chop it in half. That short side is going to be 10. That means this medium side is 10 square root of 3. Okay, so that triangle's done. Let's look at this one right here. So if we look at that green triangle, that 10 square root of 3 is now the short leg on that triangle. So we can use that. So take that 10 square root of 3 and double it. That gives you 20 square root of 3 is your hypotenuse. And then the longer leg is 10 square root of 3 times the square root of 3 again, right? 3 times 3 is 9, so square root of 3, square root of 3, square root of 9, which is the normal 3. So we have 10 times the normal 3, which gives us 30. So that one's done. And let's go on to this one here. No angles. This, I do have to put a right angle in there. We can't do this unless it's not a right triangle. So I am going to put that 90-degree angle in there. But this one, another case of Pythagorean theorem. All right, we know x squared plus 15 squared equals 20 squared. We have x squared plus 225 equals 400. Okay, so x squared equals the square root of, let's see here, that's going to be 175. All right, which is going to simplify into 25 and 7. So this gives us 5 square root of 7. And that one's done. All right. Next one, 7, 8, 9, 10. This video is getting kind of long, so I'm going to go ahead and end it here, and we'll start back up with another video.